Hello, welcome to part 2 of the OpenIPC build. In part 1 I talked about the kit we'll be using and pretty much what the project was about. In this video, part 2, we'll be actually connecting things up, flashing stuff, see if we can get it working together. So let's start with the camera, possibly the most intricate part of it because it's got little bits to try and get into. Make sure you've got this bit. So yeah, let's go take a close-up and see what we have to do next. Okay, so here's our camera board. And the way we flash the firmware on this sort of thing is a bit different than things you might have used in the past, because normally it's just a single sort of basic chip and there's a way of flashing it and you do that. Where this is like a little system on a chip, it's running its own OS, so you sort of log into it and then you have to get to a server to pull software down. And so especially for Windows users, this would be a bit weird because you'll have to install a few things on your system to enable you to host a little file to pull down to this board and get some terminal emulation software so you can actually log into it. So the way we basically get into this so we can do that is via a little console interface. So to do that we need a UART. Unfortunately, on this one, the UART, TX and RX pins are these little tiny pads just there. See those? Now, I don't have a particular problem doing this sort of soldering. I can be quite careful. It is, however, quite easy to bugger things up. I've done it multiple times, and that little resistor is very close, and it's also pretty easy if your soldering iron's too hot to take the pad off completely. Then what do you do? So I figured perhaps there's a way of not doing that. It turns out there's actually a second UART on this one, which is on these pins here. However, it's disabled by the hardware manufacturer, presumably because he didn't want people going in and flashing different firmwares. But OpenIPC tell me that once we have this flash with OpenIPC, we can unlock that and then use it. So I thought, what is a way of trying to avoid soldering onto those if we can avoid it? Because let's face it, nobody wants to do that for fun. The other reason we'll need a TX and RX on a UART, by the way, is once we get to FPV, this will be sending our telemetry information back so we can actually have an OSD. I thought the solution to this might be pogo pins. If you don't know what pogo pins are, sometimes called test pins, here's a bunch I bought earlier. They only come in hundreds. I only need 2. If I show you these, you can see this is like a little needle-like pin here, but this thing at the end, like a pogo stick, will compress. So the idea here, if we can push that down onto that contact and hold it there in some way, then we essentially have a way of connecting to these pads without soldering. So I went ahead and I tried working on a very basic model, and it took a few times to get the hole size right so I could basically push these in and not have them move. And then I checked it would fit on the board and that looked good. So that's when I soldered in some wires, which was a mistake. Obviously what you need to do is solder the wires first, then put them in, because as this heats up, of course, the PLA would melt and they'd move around. However, they're quite flexible, you can move them back. I've chucked a bit of super glue on the top to hold them, and what I ended up with is this. This is my very basic PLA print, and you see I haven't done anything other than the fact I've got it at the right sort of size, so there's just a little bit of flex in it. This is a certain size so it fits on here without damaging anything, and then I obviously put these in a place where they were just a little bit low to go on the board. So to get it on the board you have to sort of flex it up, push it along, and then as you go down it connects to those pins. Obviously if you want to do this sort of thing, I'll pop this little design on Thingiverse. It's pretty basic and I'm sure people can vastly improve it. And what I've done there is I've connected everything to the FTDI adapter. We've got this one here for the ground. You can use any ground on there. The ground I'm using is going to be this one here. There's a ground pin here. I will show you the pinout of this board. You can see there's a whole bunch of stuff. The important ones, if I take away the stuff we don't need, you can see the stuff we actually need is sort of, some of this is already plugged in, so we have a ground here and a 12-volt input. Hopefully, and we'll have to test it, we can use the RX TX pins here for telemetry and for accessing the console. And then the other important one is for connecting to the Wi-Fi adapter. This is a USB connector here, so we've got 3.3 volts the data plus, data minus and the ground. We'll be using 3 of those pins to connect to one of those little Wi-Fi modules. So one other thing to mention about your FTDI adapter is the logic. Most of them have some sort of little jumper like this. We need to make sure that is set to 3.3 volts and not 5 volts. We use 3.3 volt logic on this. 5 volts may do some damage, so just be careful there. 3.3 only. Actually attaching this thing looks like, I'm doing this in the viewfinder so it's not going to hit it first time, but just slide it over and lift up and let it go down. Hopefully you can see the pins are just touching on the pads there. So now we're ready to plug in and see if we can go ahead and flash this. Now a few people have been sort of put off by the Linux commands. In theory it should just be a case of cutting and pasting some commands. If that's it, then you don't need to know any commands. It's obviously quite handy just in case something goes wrong, but let's see what happens. Let's get on with the actual flashing part. Okay, I'm on a Mac, so I'm going to show you how to start TFTP on a Mac first off. There is an inbuilt daemon for this. It's a little bit weird how you launch it, and you probably won't have it running. You can always check that by having a look at the port it uses, which is 69. Snigger. Which isn't there. The reason I use that tau-1 is because it picks up a bunch of numbers on these datagram ports. But if there's nothing on the TCP ports here, then you are okay. So let's get rid of that. To start this up, it's a little bit weird. You need to use a sudo command, which means run as root, and then we're running launch CTL load -f, and then you point it towards the plist. For this bit, you can use a bit of order completion. Just type a few letters in and double click the escape button and it will fill in the rest for you. tftp.plist like so. And now if we have a look at that, oops, didn't do it with the tail, we should find ourselves having a little listening on 69 on UDP. Oh, it's UDP, of course it is. It's a little bit confusing because the previous instructions this said you had to do a sudo launch ctl start com.apple.tftpd, and you'll notice if we look for our TFTP daemon, it's not there. But if you run launch ctl, I should say sudo launch ctl. Normally you'd have to type in your password to do this, but I've been messing about with it, so it's still got that in there. And we do list, and then we grep TFTP. It's sitting there. This should normally be a PID ID, so it's obviously using some other method of doing it and passing it. Perhaps the launch CTL does it for it. Anyway, you can test this works by trying to get a file there. Where this works on a Mac is it looks in a directory called private TFTP boot. I have already stuck that OpenIPC firmware in there. I'll show you how to do this in a second. But if we go ahead and try and do this, it should work. Bing, like that. And if I now look at, I have to have a space somewhere. There's my copy of the file I've just picked up. So that's working okay. So we can go ahead and try and shove these into the camera now. And basically what we need to do is effectively a netboot. We're trying to get a file to install on it from our own server. So let's do that next. Okay, on my desk already I have an Ethernet cable plugged into this thing. I have my FTDI adapter plugged in. I've got my little gadget plugged in with my pogo pins, and I'm ready basically to plug in the power adapter here. So let's go over to the IPC website, where basically, I'll shortcut this. There's a bunch of installation instructions and lots of things to find out. But if you go to the pre-compiled binary files, what we're doing is looking for the right hardware for what we've got. We have a Sigma Star 338Q, which is this one here. And if we click on this, it says create an installation guide. All good. For some reason, it needs a random MAC address. It does have a proper MAC address, but it doesn't seem to have it here. Now, these cameras kind of default to using 0.123. It doesn't really matter. We can do what we like. And my particular system is on 192.168.0.10. What we do here, we make the firmware version FPV. The rest is standard. And when we say create an installation guide, and we've got some bits and pieces here. Now, one thing that Marius said is like, don't worry about the original firmware, and I did ask him about that, and he said that's because someone's already done it. But I thought it'd be interesting to do it anyway. But to do that, we actually need, at least on my Mac, to create this file in the tftp directory. So to do that, what I'm going to do is go into root, go ahead and go to my tftp directory. Well, I've already got that file, but I'll show you this in a minute. And then just touch the file we were just talking about, and then change the positions on that file so anybody can write to it, which looks like that. Okay, come out of that. And we're ready to do the next bit. So what we need to do now is open a terminal ready to sort of break in to the system or the camera and go ahead and use it. I'll talk about Windows in a minute. On the Mac we can use the screen command, and if you're thinking about what device is it, an FDDI adapter is going to come up as one of the TTY USB serial devices. So if we just have a look in dev TTY .USB serial something. Oh, too many T's. Then it's that one basically. So then we can type screen, that device name, and with a baud rate of 115/200, and that's ready to go. What I'm going to do now is plug in the power adapter to this, and then go ahead and hit return when we see stuff happening. Am I in that window? Oh, I've got a login command. I've missed it there. I don't think I was active in that window. So not to worry. This is what you'll see if it's working fine. You'll just see the boot messages. So I'm going to unplug that and start again. I find on my Mac that I have to unplug and replug the USB adapter to make this work. Oh, and that terminal's gone a bit weird now. That's better. Simply make a new tab and then we'll get rid of that crap one. Right, so let's try that again. So we'll do our screen command. I'm active in it this time, and so we're going to plug in, and I'm going to get to that. There we go, that's a bit better. So now we've got our prompt there, and you've got a bunch of commands you can use and stuff, which is exactly what we're going to do. Basically, we're going to cut and paste some of this stuff here over to the Mac or this window. So let's do the first one. Set. The good thing about this first bit, it's non-destructive and lets you check if everything's working okay. It's very keen to do one at a time. Don't try and put multiple lines in, because it has some things that, like, this may work, this may not work. Okay, cool. That was the probe, and this is the this may not exist. So let's try and see if it works or not. Nope, it doesn't have tftp put, so we'll use the next command, which is this one. No worky. Okay, so I went and talked to Mario, who said it doesn't work. Don't worry about it, but it's been backed up just in case anyone needs it. I think the reason it doesn't work is there's no tftp put command, nor is there a tftp command. There is a tftp boot command, but that means it doesn't have a sort of a put, so there's nothing there to put it. So I'm going to ignore that and go on to actually putting the image across. So what you can do here, this file, if we download it, is the bin file. You see I've already downloaded it, and that's what I put in my /private/tftp boot directory. So that's already there, but that's where you download it, stick it in your boot directory before you go. So I've reattached to our little camera once again. So what I'm going to do is go ahead and do these commands and see if we can go ahead and actually flash this now. Yep, that one's done, and this one. Okay, so this would be the thing to see if the tftp server is working fine. This command here. Yeah, that was good. So that is basically connected to our computer and pulled that file across that it's now using. So that's the alternative command, but ours was fine. So we're now going to do this next command. This command failing. I've remembered that Mario had a bit about this in his video, and what he said is ignore the SF lock. I wonder if we got commands or completion here. Yeah, we do. Okay, so that bit's there. Again, it'd be useful if they updated the commands if some of this stuff doesn't work. But there you go. So we'll just carry on through popping the commands in. This looks like it actually goes ahead and writes the new firmware. Just looking at the command, I'm guessing. Alright, and then finally we've got reset. So I'm just reading the bottom bit because it says the camera will automatically restart and boot with a brand new bootloader. Stay focused and prepare to interrupt the booting sequence in order to get back into the bootloader shell. When in the bootloader shell, remap ROM partitioning according to your flash size and type that. Okay, so let's go ahead and do this. And oh yeah, you notice it says OpenIPC now instead of the other thing, so that's seems like it's worked. And so we can go ahead and run this final command, which is that not defined. Lovely. Okay, so with that not working, what happens if we just let it boot up? Kind of guessing at this point a little bit, which is kind of annoying. No, we've got a problem there. We've got a file system not mounted, so it keeps going into reboot. Okay, I need to find out what's happening here. Okay, we're back after a slightly lengthy discussion with Mario there. As it turns out, this camera has 16 meg of flash memory, and we've got the instructions for an 8 meg camera. So Mario sent me over the 16, I keep saying gig, 16 meg version of the FPV file, which I thought I'd be able to find if I went into the 16 meg option and looked at that way. But at the moment FPV is greyed out, so we're so new on this that the instructions are lagging way behind. But anyway, there's a few changes to make. If you look at the bits here where they have this hex 8 and 5 zeros basically equates to 8 meg, so we need to change these to 10s in order to get the image right. I've also downloaded the image and stuck it in my tftp
directory. It's here, look. So I'm going to start putting these commands in, and I'm going to mix about which ones I'm using. So the setenv is common for both, and then this move B is wrong, so we've got this one here instead. Okay, and then the tftp boot is fine because it goes to a certain area, but of course my name of my boot file has changed, so I need to go and grab this one here, the 16 meg. Lots of copying and pasting, it's good fun. And why have I got an access violation there? Hang on. Oh, I stuck it there, did I? Okay. Let's just change that quickly. Oops. That's better. Right. Oop, where are we? Let's do that again. Now I've changed my permissions on the file. Mary also said that this this command here is not needed, so okay, we can get away without that. And we know from last time that the sf lock is not a command that works or is needed. So we've got that, and then we want the arrays. That's where we go over to this guy. Which is going to erase our flash memory and then write back the firmware again. And hopefully, when we reboot it, it should come up and not get stuck in a reboot loop, which would be fine, wouldn't it? So that's the arrays, and here's the write. I literally think the command is just reset. Yeah. Okay, let's see what happens this time. Alright, this looks a bit better, I think. No, it just rebooted itself. Why did it reboot itself? Well, it's worked out it hasn't got a Wi-Fi card connected, which I kind of already know. Oh, that's interesting. It's gone into DHCP now, and it's got itself a different address, 192.168.0.50. That's just going to sit there doing nothing, is it? Interesting. Well, HTTPD has started, which is interesting. Can we go ahead and access it that way? Which is port 85. Okay, well, just going to check what the root password was, because I thought it was 123456. Ah, it's 12345. Okay, let's try that again. Okay, well that's kind of working. You must set your own secure password. Okay. Should put that right. Okay. So we seem to have something on it, apart from it's not running our... Well, it's not getting a logon prompt. Oops. Because it's sort of stuck. Tells me I need to replace my original MAC address Oh, it'd be useful if I knew the original MAC address, wouldn't it? I wonder if I can get to SSH. I'm kind of slightly worried that this has stopped because it's got no Wi-Fi card. Can I just Control-C that and let's see if we can get onto it via SSH then. I don't know if SSH is running, it's a problem. What are we? 2.68.0.50. Yeah, that's better. I can log in. So, oh, I see. Yeah. It was not running a TTY. So if we, I suppose we have to do it. How do you close this bloody thing down again? User bin? Yes, we have. Doesn't contain the command shutdown. How do you reboot? Got a reboot command? Oh, okay, there we go. That's rebooting. Okay, so the reboot did work. For some reason, it decided not to log me out. There you go, of SSH. But it's got a login prompt now, so we can go ahead and do that. So we've got a console login. We should have an SSH login here. And over here, we've got a web interface on 85. So that's a good start. Well, we can obviously disconnect this, so we don't need that anymore, and we should have everything coming through the wired interface. And of course, what we need to do is connect our network card to it as well. So let's see if we can get that working. Now, if you remember for the original pinout diagram, I actually said one of these pins was 3.3 volts. I've been told that this doesn't actually put out the voltage, so we need to power up our Wi-Fi adapter on its own. So this means getting our little UBECs to work, and we've got this little screw to turn to change the voltage. Pretty simple. You just put a ground and a positive in, and then you take the ground and the positive out. So this side, let's say 4S battery, that side we're going to set to 12 volts or 3.3 volts. So I've gone ahead and wired up a couple of these, ready to see how you basically sort them out. So I'm just going to plug this into a battery and the other end into a multimeter, and then we'll try twiddling the thing and see if we can set this one to 12 volts, and I'll do the other one to 3.3, and then we're powered properly off a battery then. Okay, so this end we've got crocodile clips going to an XT60, going to the UBEC, two more crocodile clips going into my multimeter, which I'll try and light up to see what's going on. And I'm going to plug in this 4S battery, because that's probably going to be what I'll be flying with. Just make sure these don't short themselves, else that would be bad. And we'll see what we get if we plug this battery in. And 12.55 volts, which is not too far off what we want. I've just actually Bluetooth this down, and I found that an actual straight end screwdriver is best to work on these. What I do notice is they're very, very sensitive, so you don't need much of a turn. Okay, just a little part of a twist pushed that right up to 14 volts. I'm just going to move this down, and you can be quite accurate if you can be gentle enough. I mean, that's pretty much bang on 12 volts. What I'm going to do is just leave it for 10 minutes just to make sure it stays there, nothing happens, and then I'll come back, plug it in, make sure it's okay, and then I'll go on and do the second one. Yeah, that seemed to do okay. Gets a little warm. I'm not quite sure how warm I'll get, and depends how long you run them. Of course, I'm running them indoors here with no airflow. This is the second one, and you can see it's at 3.3, 3.315. I get the variance of that 0.01 volt. And having unplugged the battery and plugged it in the day later, it seems to still be pretty good about where it is. So what I'll probably do, of course, is cover this in a bit of heat shrink, maybe get myself access to that screw,
And then it's going to come to wiring this guy up. So let's have a quick look at the pinout, shall we? Now you notice I haven't labelled all the pins. Some of them I didn't know what they did. They were sort of labelled in the original description on AliExpress, but who knows. There's also a bunch of other grounds around which we may use, because I intend to obviously solder on this guy to my DC in and my ground, and then take my ground and my USB D- and D+ to the board via an adapter, if I can find a JST adapter that will fit that. And obviously you need to cross over the D-, D+. So D- goes to D+, and D+ goes to D-. So I'm going to do that now, and I'll see if I can share the ground. If not, I'll just connect to another one for the other side. Obviously before powering up, I need to pop some antennas on these. These apparently speak both 2.4 and 5.8. I've got loads of 5.8 stuff, so we'll find some 5.8 antennas. I've also been told, with no heatsink, these run very, very hot. Obviously, on the outside for FPV, you'd be cooling them down. I don't have a heatsink. I do have a fan, so I'll whiz some fan on it when we actually come to power this. And we'll see how that goes. Okay, so what I've ended up is this. I've got my little... this has actually got 4 holes, so it sits perfectly in a slot, but just with the correct ones there. Obviously we've got ground, D+, D-, whichever way it is, and then we've got the 3.3 volts, and I've used another ground over here because these are very small points to solder to, and I've just got this ready to go on when I'm ready to heat shrink that. This is not probably how it would go into, like, you know, a plane or anything. This is just for demonstrating here. Before I did that though, I also made up this little adapter to see if we could use that second UART, and I thought the easiest way of testing it is to see if I can log in on there. Now I'm not sure if that's going to be just ready to go if I plug in and expect anything to happen, or I might have to do some work. Also, I feel this is probably a good point just to go over quickly the Windows route to setting up both serial terminal emulation, SSH, and your tftp server. So let's do both those things next, and then we'll plug this guy in and test it out. Okay, I've gone ahead and I've powered this up, still on the wired network, and I've got my UART2 going into the FTDI adapter. So if we turn to the computer now. Okay, so when I first simply tried opening up the terminal using the screen command, I didn't get anything going. So what I did is SSH over to it. Oops. When you're SSHing, it will take the user you're on, so sometimes you've got to just tell it which one you want to use. So yeah, what I did is I had to go in and edit init tab. And if you look at this line here, this is the thing I basically copy and pasted. I thought it might be TTY S1, but it wasn't. It was S2. Just a bit of general trial and error to get that. I can't. This is the Vi editor, and I don't really have time to say this is how you use it and stuff. It is not a simple go around and type stuff. It's like I to insert, it's X to delete, it's like :WQ to say write and quit. It's a bit weird. If you've used any sort of Unix before, you'll know it, and I'm sure there's plenty of tutorials on the web if you need to use it. But anyway, that gives us the ability to go ahead and run a normal login. And this is just used just to make sure it's working, basically. When it comes to actually using this for FPV, we can't have a Getty, which is the name of the login script that running on that port, because obviously we need to use it to send stuff. But just as a check to make sure it works, and something that gives us sort of a backdoor in if stuff goes wrong and we don't have to use those little pads, quite useful. Anyway, let's now flick over to Windows to see what we need to do to set things up. Okay, Windows users, so this is what I basically did. I downloaded Putty. Putty is a free SSH, and it can act as a terminal emulator. Kind of looks like this, and what you can do is basically set up SSH here, or
serial communications here, and what I did is I went ahead and saved myself some settings. So if we load that up, we'll see we're command line COM6 and our speed is 115.200. If you're unsure about which COM port you are, if you go into device manager, we can see there USB serial port is on COM6, so we got that. I've got the thing plugged in right now, so I should just be able to double click on this, hit return, and I can log in via that serial port. If you're wondering why we haven't got any of the login messages, that only appears on the console and we're on a different one. You can look what's going on. If you have a look at dmessage, it'll tell you the last load of stuff, not necessarily all the login messages. PuTTY as well, open it. You can use SSH as well, so with the same IP address on here, 192.168.0.50, and I can just log in there quite happily. PuTTY also installs a command set on the command line on Windows, so you can use things like SCP, a way of remotely copying files back and forth, which we'll need to use later. tftp server wasn't as clear. I had a look around. I found this one from SolarWinds, which seems okay, and is, where is it? It's down here somewhere in the view more section. There it is. And if you go and download this, it will ask for all your details. As you see, I've made up loads of details. That's not my phone number, this isn't my name, and I think I had squigglebiggle@gmail.com, and it seemed to accept that, and I downloaded it. What you then get there, just get rid of these, is eventually this thing, which says we've got a TFTP server starting. What it does is, by default, it lets you TFTP to TFTP -root under C, and you see under my C directory there I've shoved a file in. Now this won't probably work straight off the bat because of the way Windows firewalls work. If I try and TFTP to that from my Mac, and I need to know what the IP address is. This is a little bit weird because where I'm on a VM, it sort of has its own network on this like 172 thing, which is not my normal network, so it sort of thinks it's on a completely different network, but it bridges across. It's a bit weird though. You'll notice a bunch of nothing particularly is happening there, and that is pretty much down to the good old firewall. So what we have to do for this particular time is turn it off for public networks, and then hopefully so as you can see there, we managed to get that file across, which seems like it's working. And if we look back on Windows, we see a bit of logging there to say it actually happened. So that is a very brief idea of how Windows is set up. Basically, PuTTY, this TFTP server from SolarWinds seems okay. I don't know anything about the company, but it seems all right. And that will get you into here, so you can go ahead and at least set it up and do the flashing that way. So that is Windows. So let's get back to actually plugging in the Wi-Fi adapter and making sure that all works. So how do you tell that the Wi-Fi adapter is working? Well, what I'll do is show you what happens when the Wi-Fi adapter is not powered up, and then when I power it up you should see the difference. So if we go ahead and SSH into the type the password first. If we SSH into the camera, two things to look for. The actual piece of code responsible for sending the video is Wi-Fi broadcast, or Wi-Fi broadcast, I think it's NG for next generation or something. And if we look for WFB in the process list, we don't find anything. And what we could also do is say Wi-Fi broadcast start, and it will say can't find it, which makes sense. So if we come out, what I'm going to do is I'm going to unpower the camera, and I'm going to plug power into the Wi-Fi adapter and then repower the camera. So what we have there in this jumble of wires is the Wi-Fi adapter here. That's plugged into a Forest battery via the back. We've got the normal serial cable, the camera, and we've got a fan pointing on this one so it doesn't overheat. So if we go ahead and SSH into that now, and we have a look for WFB, we can see it's running there in the processors. So it's obviously found it, and we can have a better look at that by stopping it and then restarting it. Don't worry about the problems in the shell script there. So if we go ahead and start it this time, we can see that it's found that we've got a Wi-Fi card and a vendor, and basically that starts that up. So if we say we go back and look at it, there it is on a new PID ID, and that's running. Obviously, because we haven't built the ground station yet, we can't check anything's working other than the fact that we can see that the board has been identified and it's saying it's like sending stuff. Well, that's all good. Okay, so that's the air part of the equation done. So now we're going to talk about the ground station using the NVE board. And I just want to go into close-up to show you a few things we need to do there. Hopefully, because we already know kind of what we're doing with how to flash stuff and bits like that, this shouldn't take as long. I appreciate we're already over 40 minutes, but I want to do the whole video doing the ground station and the air bit, if you like. So right, into close-up, let's check this out. Okay, the NVR board, at least I think that's what it's called, I can't remember, NV something. This should be a little bit more straightforward. The things of interest here is the power. It doesn't actually say what it is. I just checked the continuity and it appears that it's well, it's 12 volt, it tells us that, and centre positive, looking at where the grounds go. We've already got two USB ports here. We've got an Ethernet port, we've got HDMI and VGA out, so we should actually be able to get something on it. So in terms of flashing, it's a little bit more straightforward in the fact that we can actually see the pins properly, and not only that, they've gone and labelled them for us. Do you see there? We have ground, TX and RX. Not silly little pads, we've got through holes. Again, it's still quite close to other components, so you have to be careful, but for me, I feel this doesn't need the pogo pin approach. A few more of these, I'm going to poke those through, just put a little bit of solder on. Being careful, as I said, I'm going to poke through from the top and just solder a little bit at the bottom, and then these can stay in place if need be then. Yeah, and that should be it. There's not much more to say about this one other than let's get started. Oh, there was one more thing. One of the things I just thought about is these USB ports obviously are 5 volts, but our little Wi-Fi adapters use 3.3 volts. So I'm presuming what we're going to need to do is power this independently and only wire up ground D plus D minus into one of those USBs. I will double check that obviously before I do it, because first off we need to get this connected in much the same way. So we're going to add Ethernet, we're going to add power, we're going to add the console and power it up, break into the bootloader and try and flash the OpenIPC firmware. Let's do that next. Well, in retrospect, maybe pogo pins weren't such a bad idea. The problem was these, I couldn't get the solder to stick very well, and then you end up using too much, and then we had a short between that one and that one, and it was getting very close to there, so then I switched to over there. Anyway, it's connected, it's not shorted, it should work. It's sort of a temporary thing. I will take those off after, because I don't like it. What we really needed was something that could just poke in there and create a nice little set of pins, but I didn't have any that were the right size. They're not servo size pins, they're much smaller than that, but anyway,
let's try booting it up. Okay, so just to check that works, I have got my USB plugged in. I've got an HDMI cable plugged in to see what comes on the screen, and I'm just going to push this in and then see what comes up on the screen. So let's do that now. Pushing the power cable in, and yeah, we've got some stuff happening on the screen there, so that's good. And I'm just looking at my gaming monitor, and that seems to have something coming up there as well. So that certainly works. And yeah, essentially it just says starting kernel. And is anything else going to happen to the screen? Yeah, we get this. What this is for, I think, is those sort of security monitors where you put a load of camera feeds in and you could do stuff with them. Odds on I could plug in a mouse and do something, but obviously we want to do something else with this. Right, so what I'll do now is reset that connection and then see if we can break into bootloader. So I'm just going to repair it. Make sure I'm in that window. Nope, I did not get that in time. Let's try it again. Okay, here we go. Pressing the button a lot. Yeah. Well, I'm not able to break into that, it would seem. I wonder if there's a different method. I haven't really read the instructions about this at all, so let's see what we can do. Okay, well, I should have had this page ready to go, shouldn't I? This actually says to go to U-boot. You do a Control-C at power on. Another little change, or one extra thing I did since just testing it out, is to add the wired Ethernet cable, because of course we're going to be on the network to do that tftp boot. So I'm going to plug in again, see if I can hit those Control-Cs and get to the a prompt where we can type this stuff in. Okay, there's my console. Plug power in. There it is, and hit that Control-C. We have interrupted. Right. If we have a look at the instructions, it tells you about downloading the image here, and you just click on that and download it. I think I already downloaded that. Let's just have a look. If we have a look inside, no, it's on private. No, I don't. I thought I did. Let's grab hold of that then, unless I just haven't put it somewhere. So click on the image. It's a slow download, this one. God, that was a slow download. Anyway, we've got that file. We just need to put it in the right place. Where am I here? I'm in home. So if we go to downloads, we should have a few files around here. That's the one I want, so I'm going to copy this one over to, and obviously if you were doing this on Windows you'd stick it in the appropriate directory. No permission to do that, of course. Let's just go and use it as root, shall we? Same command I did before, which is this one. Okay. Let's just check the permissions on that file. What we got there? It's read. Good enough. Okay. So back to this guy, and then this screen, and we're going to start doing this. This is, we need to do some changes here. This is just set up generically. So let's sort that out for us. If we use our client address as 123 again, and our server address is going to be, well, not that.
Bajum. And then we can do this thing because that's normal. And then let's see if we got that tftp thing right. Like that. Yeah, that looks good. We don't know if probe and lock works on this one, but we'll have a look, shall we? See. Because this is a completely different device. Yeah, didn't seem to have a problem with that command this time. And then let's do our actual flashing, which should write our new firmware. At least the commands seem fine for this one. No falling over, no getting the wrong image. This seems fairly straightforward, certainly compared to the last one where we seem to hit every single problem available. Oh, the erasing took longer than the writing. Okay, and then we do the reset. So let's check that works okay. And we can see it's gone ahead and an Ethernet address there, buzzing about with different screen brightness. That's because it's sorting itself out, checking for the HDMI display, and because it works as a second screen, 1, 2, 3, 4, 5, it screws it up a bit. Okay, we got OpenIPC there, and guess what? If I look across to my monitor, we got this. So that seems a lot easier, doesn't it? And let's just check we can SSH into this guy. Oh no, that's the... Let's change the password while we're there. Okay, it's looking good so far, but before we go any further, let's set up another of the little Wi-Fi modules and talk about how we wire that in. Well, the difference between the MVR board and the camera is this has actual USB sockets, but the question of how we're going to get that into there is a slightly different one. My first thought was, hey, I've got a few of these guys left over from building stuff at OpenHD, but that is the wrong gender. Now, I'm sure you could get things of the right gender, i.e. ones that will plug in there and not just bash up against each other. But what I've also got, and what you might have, is so many spare USB cables. So what I'm going to do is just snip this, check continuity on the pins, make sure that's all right, and if that looks good, then I'll solder on like that. And this is actually quite a good thing because these cables are very nicely shielded. You don't want them any longer than they need to be. This might be a bit of a temporary thing for me because I don't know how this is going to fit in stuff in the future. But yeah, I'm going to hack this open, get this wired onto that, and of course I need to set another one of these little guys to 3.3 volts to power that. So we're not going to be wiring up all of the pins on this. We're going to be leaving the 5 volt off and making sure that we power 3.3 into the little Wi-Fi board and ignoring the 5 volt pin in the USB. Okay, so after a bit of soldering, what I ended up with this, we basically cut that off. I used my multimeter and continuity to work out which was ground and which was D minus D plus. Obviously ground was happily color coded, as was the 5 volt, which we've cut away, so that's wired up there. And we've got another BEC which I set to 3.3 volts to supply power, and the ground there. Not particularly suitable antennas because they've got these big bits here. I'm scrabbling around a little bit for UFL antennas. I don't really have many kicking about, but
this will do to test it. So we can now plug this in, this guy, and run it up and make sure it finds the adapter. Okay, right, this time we've got the battery going into the back, going into the new Wi-Fi module, which is then plugged in via USB on the NVR board. Now, confession time. When I first used this, I noticed WFB wasn't running, so I figured I must have D plus D minus running the wrong way, so I flipped those over to check it out this way. So if we go ahead and SSH in, oh dear, I had to put a pound sign there. That's better. We've got OpenIPC shows up, of course, and if we go and grep WFB, we see that. And just to do fun things, if we do Wi-Fi broadcast stop and then start it up, we should get all the gubbins telling us it's found our LAN adapter, and that's all good stuff. And if we check our screen, no difference there. It's just like, yep, I'm still on OpenIPC, nothing's happening. Now you probably think, oh right, now let's just plug in the other one and we'll start seeing pictures, yeah? Sadly not. So Wi-Fi Broadcast Next Generation uses an encrypted stream to actually send the data down. So we have to generate some keys and move them around a bit. So let's do that next. Okay, so the keygen thing, there's no documentation at least I could find on the OpenIPC, and that's probably because it comes from WFG, or WFB-NG I should say, and it's sort of a little footnote down here about run WFB keygen and then you get a key and put the drone key to drone and GS key to GS, and they need to go in ETC, which sort of ties up with what I was told. So let's go over to the ground station, and then we're going to run WFB_keygen. Okay, so I guess that puts them in the local directory, which is root. So what I'm going to do is copy the gs.key to etc, and if I now look at etc, oops, God, my typing, terrible. We have the GS key sat there, that's good. Now, the question of how you get your other key off there is the use of SCP. So to do this, I'm just thinking, well, do I remember the command syntax first? I think so. SCP username at hostname, which is 192.168.0.51. And then, ooh, is it that? I think it is. And dot means just copy it to current directory. And it's going to prompt password. Oh, that's because it's not in etc. Duh. It's in root. Okay, so if we now look in my current directory, we've got the drone key there. So now what we're going to do is get the camera plugged in and transfer it to there. With both the camera and the ground station, I'm deliberately using the hardwired Ethernet cable, and it just happens to be power in this case, just because it's much easier to SSH to it. So just to confirm I'm in the right box, yep, that doesn't have anything. And if I go here, what I want to do is say the other way, SCP current directory drone.key to root at 192.168.0.50 and stick that in etc. Oh, that's it. I was in the wrong window is all. There it is. Let's try that again, but this time using the right window. I was just in a different directory there.
Okay, that looks better. So if we now go onto this host and go to etc, we have a drone key. Hurrah! That's good. And is that it? Not quite. One more thing. There's one more little file to mess around with. Okay, and that config file is called WFB.conf for Wi-Fi broadcast. So if we go and edit that, there's a whole bunch of stuff that annoyingly I don't know and I can't really find out what the answer is. But the important one we need to change is the channel. This channel at the moment, channel 14, is a 2.4 channel. What I'm thinking of is 165, which should put me at about, well, actually 161, which is about 5805, which is pretty close to 5800. So I'm thinking should be okay for my standard 5.8 antennas. So I'm going to put in 165 there. There's probably some other places we need to figure out what to do with it, but I'm going to ignore it for now. And I'm going to boot up the ground station and do the same thing. And this is the ground station file. Looks almost exactly the same, except it says unit equals GS instead of drone. So again, I'm going to go and change that to 161. Save it. And at this point, I think we should be able to plug everything in and see what happens. So yeah, let's give it a go. Okay, well, it says we got packets, and it says we've got like about 4 megabits, well, yeah, 4 megabits per second or so. Everything is plugged in down here, and it seems to be working. Apart from the fact we've got no picture. Picture is definitely needed. Check it out. We have a picture. Do I look weird looking in the phone and seeing my face kind of like that? That looks odd, doesn't it? So what was wrong there? There are another 2 files that I didn't know about. One on the server and one, or I should say ground station, and one on the camera. 2 completely different files, which is kind of weird. I'm just trying to work out if there's a way of easily showing what the... I mean, I'm just doing that, and it looks pretty good. I'm not seeing any real delay there, but of course I'm pushing it over that far, there to there. That's not an awful long way, is it? But let me show you these files, because there was, again, it's not that there's no documentation anywhere. There's some documentation in the etc directory if you look at it, but nothing's really very explained. So let's take a look at these and I'll show you what we got. But look, we've got a picture. It's kind of working. So firstly, on the ground station, you've got this file called video.conf. Now I've already gone ahead and edited it. And there's not too much to it. Basically, the thing I changed was the codec from H.264 to H.265. I kept the mode currently at 720p 60, and that's pretty much it. Everything else was untouched. If we diff the 2 files, do we have the diff command in this? We'll find out in a second, won't we? That's the original that I saved, and yeah, so all I did was literally change it from H.264 H.265. Seems pretty easy, doesn't it? The problem is on the camera end of things. This is where it gets a little bit complicated. And I was asking Mario, saying, look, I've got all these like packets coming in, and it's telling me it's got this bit rate going, but I've got no picture. And he said, oh, can you send me your majestic.yaml file? I'm like, you what now? So if you look hard enough, you see it mentioned under Majestic Streamer, but this sort of stuff in here is complete uselessness. There's nothing that says do this, do this, do this, and then edit this file to set up. So it's kind of like you have to read this massive config file to try and work it out. Let me show it to you. Okay, so we're logged into the camera and I'm in the etc directory. What you've got in here is the majestic YAML file. That's the original, and the suggestion was if you look in majestic.full, you'd learn all about it. And you know, maybe you would, but I'm not sure you'd learn like these are the like essential things, these are the really important things. Some of it's like pretty obvious, like in image you've got like a mirror and a flip and rotate, some contrast stuff. That's good, we like that, that makes sort of sense. Things like night modes, but some of the other stuff like the video zero, that's a very important bit apparently, and it kind of tells you stuff, but it's like has a bit rate there, but doesn't really spell it out enough in my opinion about what can be done and what's like, you know, this is your good starting point, because clearly the one I had wasn't working at all. If we diff those files, if we look at the original, which was here, and basically the one I got off Mario and used to make my changes, there are a significant amount of differences. Like we disable web admin, we do things with the contrast and saturation. The biggest thing was on video 0, where we add the bitrate of 12288. We take the codec of H.265. We change our size to 720. This can run higher, but I'm running 720 to see how it goes. Yeah, and there's just bits taken off. We changed that to false, and we changed some of the motion detect stuff, not that it should ever be used. So yeah, I mean that's a little bit tricky to obviously work out. And I struggle a bit to say, like, how do I share this file with you? I mean, I can share it on my screen, and hopefully what I can do is when I write this up in some way and publish it, probably at least on my website and hopefully on the OpenIPC site as like an example configuration, you can take this and, you know, it starts to work, and then you can go and play with it and do things with it, because that's really what I think it's lacking. I think this video has been going for a long time. Let's start to summarize at this point, shall we?
So at this point we've got the firmware flash to both devices, we've got the Wi-Fi modules attached to them, we've got the power sorted out, and we've done all the configuration, and finally we've got live video being sent from one to the other. Hooray! So I want to stop the video here because it's already over an hour, and that's insane. And I don't know if people are making it all the way through the video. Let me tell you, if you had a hard time watching it, I took even longer to make it, so you know, there's that. You might be wondering why I didn't just cut all the stuff out where I was struggling, or I did something wrong, or I had to stop and ask a question. Well, first off, if I hit every single error possible and show what happens and how I recover it, if you guys hit the same problems when doing it, then you might have a better idea of how to do it. Secondly, that was just the reality of the situation. Quite honestly, if I just had the base documentation on the OpenIPC website, I would have given up. It's just the fact that I literally had Mario sitting on the other end of Telegram, who I was pinging loads of questions at, who could answer me, that was the reason I managed to get through it. Once you understand all the various steps to do it, it's not too bad, but because no one's actually written all those steps down in a basic order to follow, it's a bit of guesswork there, or just asking people. Now, I've discussed this at length with the guys at OpenIPC, mostly Mario, and to be fair, what they've told me is they are prioritizing the code, which is another way of saying we're not writing any documentation because we're busy doing the exciting coding stuff. They would advise, if you get stuck, that you get in touch with their open Telegram groups, and there's a specific one for FPV, and there's inside that there's like hardware and setup and all sorts, and you know, the helpful people there, all good. And they would say, hey, if you don't like the documentation, it's an open source project on GitHub. Please write documentation and submit it, and we will add it to our repository, and then other people would be able to benefit from that. The only problem here is it's kind of a catch-22 situation. They'd love people to create docs that explain how things are going and how you set things up and stuff. But in order for someone to make the effort to actually create a doc, they have to be quite invested in the project itself. In order to get invested in the project, they have to basically be able to set it up and understand it and run it and stuff like that. At the moment, what's happening is people are coming to the website, looking at it and saying, I don't get it, let's move on to something else. So they're not getting people into sort of this stuff out that would be motivated to create this document is the sort of problem there, unless the initial documentation is better to start with. So what I will do, as I mentioned before, is actually create a document based on this video that takes it from start to finish, and I will be sort of missing out this time all the things where it went wrong. I'll be pointing out the bits that are wrong on the website, the bits you don't need to do, and basically writing that down. And hopefully I'll be able to put that on the GitHub site, and I'll put it on my webpage as well. At least then I've got my own record, because I often have to refer back to my own stuff sometimes if it's not clear anywhere else. I think what confused me a lot with some of the setting up there is the fact that I thought it was all OpenIPC, but it's not. OpenIPC is one of the things. That's the firmware that gets replaced. It essentially runs this little Linux. It was the stuff like WFB-NG and Majestic, which I didn't really know anything about, and there's no documentation at all, because they say, oh, go and look at the documentation on their GitHub repositories, but that's not really very helpful, and I didn't really understand it very much. It's another thing for me to research a bit more and understand. Just give me a little while on that, because I've been working on this for multiple days and I have to do some catching up on something else, so it's not going to be instant, but it'll get there, don't worry. Now again, this is only going to document how to set up this camera with this ground station. But what I figure is if you have like a base set of instructions, it's easier to understand how to sort of swap various bits out. So if your camera slightly changes, then you know that you need a UART to flash it and how to connect that, and then you hopefully can follow the instructions on the website about which version of firmware you have. One thing that also came to mind today after editing those last couple of config files is, yes, you probably do need to know a little bit how to use Vi. Vi is a general editor that's available on all Unixes or Linuxes. And it is pretty simple, but I used it for years and years and years, so everything is second nature. It's like, it's just simple to me, but it's not simple if you're used to sort of, a Windows thing where you just cursor along and delete things and then add things without pressing things like X or I or A to append and things like that. So I'm going to stick a little... I looked at some tutorials today. I was looked for the sort of simple one that basically gives you sort of the key commands, and all you're looking for is like literally X is delete, A is append, I is insert, and every time you stop doing that you hit escape. And little things like colon right quit or WQ to make it right. These things. Anyway, there's a tutorial listed down below in the description, so check that out, especially you Windows guys that are probably not familiar with it, and that you'll make more sense of it that way. So in the next video, part 3, we'll be looking at more about the FPV setup. So right now we've just got video being sent. There's an OSD, but you will notice none of the OSD is doing anything because it's not connected to a flight controller. So what I want to do for next time is connect a flight controller, understand how we get the telemetry from the flight controller in order to populate the OSD with bits and bobs. Also, I want to delve down into more of those video settings. At the moment, this is running 720p 60. We can run at 90 or 120 frames. We can actually run it at 4K at 20 frames, I think. But I want to mess around with the things there to see what's good and what sort of impacts it has on latency and performance, that sort of thing, just to mess around. Again, give me a little while on this one. I've got a bit of a backlog of review stuff to get through, so it's going to take me a little while, but I figure you guys hopefully can get to your flashing stage and get your cameras and ground stations talking to each other, and that gives you a good start. Fingers crossed. Anyway, hope that was helpful. If you reached to the end, congratulations. I have to now watch the entire thing back to make sure I didn't make any mistakes. And I will catch you in the next video. Bye for now.
Well, you've made it to the end of the video, so thanks once again for watching. If you like what you saw, then please consider subscribing. And if you really like what you saw, then be sure to check out the link to my blog for a variety of ways in which you can help support this channel.